we now go into the slide discussing about how do we want to prepare the samples containing organic analyte for liquid sample. Okay, same like what I gave to you for digestion before, and also solid liquid extraction. The same diagram we show you. We have like four like this. Okay. For organic analyte, we have liquid extraction, solid phase extraction, and also we have more state-to-the-art solid phase micro extraction and stir-absorptive extraction. Okay, I will start with liquid extraction. It is abbreviated with LLE, and in recent years, scientists has come out with a simpler method and also using low amount of organic solvent to do the work. So we have liquid micro extraction as well as dispersive liquid micro extraction. And then for SPE, we have the conventional SPE using cartridge and also using particles adsorbent. Okay, unlike this liquid extraction, we use liquid. Okay, we have cartridge SPE, the conventional one, and then we have micro SPE. For SPME, it is using coating adsorbent and coating adsorbent for SBSE as well. Okay, so you can see that this three here is a solid phase extraction, while this one is liquid phase. Means that liquid extraction is using liquid to extract the analyte from the liquid. Okay, so liquid extraction is known as solvent extraction and using partitioning principle. Okay, means that we want to partition analyte from phase A to phase B. For example, if you want it is originally inside A, but you want it to be inside B for different kind of reason lah. Okay, the same thing if you have B, you want to put it inside A. So we use liquid extraction, and conventional liquid extraction is using the 100 ml size, or can be up to 500 ml of separating funnel, whereby we have our solution. Okay, we have our sample, and then we top up with organic solvent that won't dissolve our sample. Means that it has to be different density data. Okay, we have lower density at above and high density on the below. Usually if it's a water sample will be here, and organic sample will be organic solvent will be at the above layer, for example hexane. Okay, so maybe you have a hydrocarbon inside here. Okay, hydrocarbon carbon, CH, methane, whatever lah. And then you want to be inside hexane. You want it to be inside hexane because sometimes instrument would like to have solvent as their carrier. Sometimes instrument doesn't like water. For example, GC, gas chromatography, doesn't like water at all. So you have to think on how to make sure that hydrocarbon is dissolved inside organic solvent. So you do liquid extraction. So after some equilibration, you collect your analyte, hydrocarbon for example, inside the new phase. So this is the new phase. Original phase here, new phase here. Okay, same thing like here. Okay, this method is based on solution preference to go to which phase. Okay, for example, hydrocarbon really love hexane, so hydrocarbon will go to hexane easily. Hydrocarbon doesn't like water. Okay, so water will be left and go into hexane. It is an extraction of substance from one liquid phase, we are talking about liquid sample, into another liquid phase. Okay, so this is what I said just now. If let's say this is your organic solvent, this is your water sample. Okay, after some shaking, okay, vigorous shaking, you can ensure that anything from here go here, or anything from here go here, depending on the preference. Okay, so this is the procedure. Okay, I will show you some videos so that you can like imagine how it's done inside lab. Okay, maybe you are going to do this in lab practical as well this semester, I guess. Okay, so you have a sample in separation funnel, and then you put solvent. Okay, the calorimeter is a solvent. You see that the volume is usually lower than the original sample. You shake, and then you collect organic solution and aqueous solution. And if you want to have more analyte, you do this several times and then repeat. Then evaporate, and then you do analysis. Okay, in this procedure, okay, I show you micro LLE. Okay, but I will show you the original conventional LLE first, whereby the sample is usually up to 100 ml, sometimes can be 250, but this time is only 50 ml, and evaporate down to 1 ml. Okay, so this is micro LLE. Why micro? Because we only take microliter of that organic solvent containing analyte into instrument. Okay, advantage is that it's really simple. It doesn't need any cartridge. Unlike solid phase extraction, it need cartridge. Therefore, in liquid extraction, you only use Falcon tube, for example, and then you find solvent that is chemically correct, and then you have sample shake, and then you have syringe to take the desired phase. Okay. However, because it requires volumes of high purity solvent, it is hazardous to be discarded. Okay, means that you have to think on how to discard them. Okay, this is the conventional liquid extraction. Okay, let us see first. Berapa minit ni? 3 minit, 3 minutes only.
The technique of liquid-liquid extraction is a form of solvent extraction which is often referred to simply as a separation. We do this using a separating funnel as shown on the screen. The technique can be used in a range of contexts, and it's important that you understand why you're carrying out a separation in the experiment that you're doing. In this demonstration, we have a solution of a product of a reaction in an organic solvent, which in this case is diethyl ether. We are going to wash the solution with water to remove impurities which are water soluble. The first step is to remove the magnetic stirring flea from the reaction flask. We need to wash this with ether to ensure that we don't lose any of our product. We now need to pour the solution of our product into the separating funnel, taking care to avoid any spillages. So it's wise to use a small glass funnel as we pour. Then we can rinse our reaction flask with more ether to ensure that no product is lost. Now we add the water which we're using to wash our reaction mixture with. It's important that you pay attention to your script, which may specify a different solvent and a particular volume that you need to work with. Next, you need to place a stopper in the neck of the separating funnel, and you must ensure that you don't allow this to fall out at any point while you're handling the apparatus. Secure the stopper with one hand and carefully invert the separating funnel. Now you can gently shake the funnel while periodically opening the tap to release pressure. Normally you carry out these steps several times to ensure thorough mixing of the two layers. And then with the tap closed, you can carefully replace the funnel in the ring on the clamp stand. Here you can clearly see the two separate layers in the funnel. In this case, the denser aqueous layer is at the bottom and the ether layer is on top. However, you should never make assumptions about which layer is which, and you may be given instructions that tell you how to test which layer is organic and which is aqueous. Before running any solvent out of the funnel, you must first remove the stopper. Not doing so is a common error which will prevent the solvent from running freely. Now you should place an appropriately sized conical flask under the separating funnel before carefully opening the tap to allow the lower layer to run out. You should watch patiently as the interface between the two layers moves towards the tap so you are able to stop the flow once all of the lower layer has been removed. Remember that in this case, the lower layer was the aqueous layer. Now you can remove this flask and place a second clean conical flask under the separating funnel to collect the upper layer. As always, you should check your script to see what you've got to do next. You may be expected to return one of the layers to the separating funnel to carry out further extraction steps. In this case, however, we are simply going to dry the organic layer using magnesium sulfate. Other drying agents that may be used could include calcium chloride and sodium sulfate, so make sure you read the script before proceeding. If the drying agent forms clumps as shown here, that's a sign that the solution is still wet and that more drying agent is required. When you can see a snowstorm effect like this, you know that the solution is dry and that no more drying agent is needed. You can now remove the drying agent by gravity filtration before consulting the script once again to identify your next step.
Okay, so you saw how LLE is done in separating funnel. Okay, you see 2 layers are obtained after some shaking and also releasing the pressure. Okay, and now we'll show you the video on micro liquid extraction. This is very important to be shown to you because most of the time in forensic lab or even any chemistry lab want to use the reduced size. Okay.
Remember to wear gloves and perform extractions in the hood. Here's what you'll need. Some Falcon tubes and Pasteur pipettes. First, add the aqueous layer. Now add the organic layer. When you have your 2 layers, cap the tube. Now give the tube a good shake. After shaking, it's important to loosen the cap a little bit and vent the tube. Repeat the process of venting and shaking the tube about 4 to 6 times.
If you don't want to shake, you can use
When you're
what
done,
we call as
let the
vortex
Falcon tube
mixer.
sit still to allow the layers to separate completely.
If you want to separate these 2 layers, you can use centrifuge machine. We have it inside forensic practical lab.
To separate layers, grab yourself another Falcon tube and a Pasteur pipette. Make sure that you push air out as you lower the Pasteur pipette into the Falcon tube. Lower the Pasteur pipette all the way to the bottom of the Falcon tube. You only want to draw up the bottom layer
You want to have the bottom layer because that's where your analytes are in.
and transfer it to the new Falcon tube.
So do this with precaution because you might actually take the colorless layer as well, which is not desired in this case.
If you do this correctly, you should see only 1 layer in the new Falcon tube. Here's an example of what not to do. On the right, there is an aqueous layer with some organic on top. You want to try and separate the layers as much as possible and not bring organic along with the aqueous layer.
Remember, we have to inject homogeneous sample inside instrument.
At this point, you've completed your first extraction, but there may still be some organic product in your aqueous layer. So, take your aqueous layer and add fresh organic solvent and shake it, vent it, leave it, and extract out the aqueous layer again.
You
Do
can
this a
repeat.
minimum of 2 more times. Sometimes during extraction, you might get what's called an emulsion, a dispersion of 2 normally immiscible solvents in the form of droplets. If you have an emulsion like we have here, you want to try and clear it up. Make quick, fast swirls of the tube. You could also try adding some sodium chloride solution. You want to make sure your emulsion is cleared up before you try separating the layers.